Hey there, day 10 of Advent to Code 2022. Let's dive right in. Cathode ray tube. You avoid the ropes, plunge into the river, and swim to shore. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritize getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining out of the big crack in its screen tells you it won't be much use immediately. Yeah, sorry. Unless, that is, you can design a replacement for the device video system. It seems to be some kind of cathode ray tube screen and a simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent by the CPU. The CPU has a single register, X, which starts with value 1. It supports only 2 instructions. Add to X, V takes 2 cycles to complete. We're going to really have to delve with what 2 cycles means. After 2 cycles, the X register is increased by the value of V. V forewarned, V can be negative. No op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program, which will be the puzzle input, to somehow tell the screen what to draw. Consider a small program. No op, add 3 to register, add negative 5 to register. The execution proceeds as follows. At the start of the first cycle, the no op instruction begins execution. During the first cycle, X is 1. After the first cycle, the no op instruction finishes execution, doing nothing. At the beginning of the second cycle, the add X instruction begins execution. During the second cycle, X is still 1. During the third cycle, X is still 1. After the third cycle, I just realized when I skimmed the instructions before recording, I've missed this part. After the third cycle, the add X3 instruction finishes execution, setting X to 4. At the start of the fourth cycle, the add X negative 5 instruction begins execution. During the fourth cycle, X is still 4. During the fifth cycle, X is still 4. After the fifth cycle, the add X instruction begins execution, setting X to negative 1. Maybe you could learn something about the value of X registered throughout execution. For now, consider the signal strengths, the cycle number multiplied by the value of the X register, during the 20th cycle and every 40 cycles after that, 20, 60, 100, 140, 180, and 220th. For example, consider this larger program. We could read this later. The signal strengths can be determined during the 20th cycle. The register has a value of 21, so we multiply 20 and 21, get a signal strength of 420. During the 60th cycle, the register has a value of 19, so we multiply 60 into 19, get a signal strength of 1,140, and so forth, 4 more times. Add up those 6 numbers, and we're going to get what the puzzle is seeking. We're going to find the signal strengths during the 20th, 60th, 100th, 140th, 180th, and 220th cycles. What's the sum of these 6 signal strengths? So what I thought we'd do is draft some pseudocode here. So the goal is this here. We're going to find the signal strengths during the 20th, 60th, etc. cycles. What we need to do is read in the puzzle input like usual. go through all of the instructions. There are two branches here if we see no operation and if we see addx. If no operation, we simply add 1 to cycle number. And if I'm reading this correctly, for addx v, we add 2 to cycle number, update register x value. And it has to be in that order. We go through the cycles, update the cycle number first, and then register the values. And then we'll do that part there at the end. Hopefully that works, and we'll see how we do. I'm gonna have my puzzle input loaded here. The example right now, and that corresponds to this fairly longer example here. What I'm going to want to do is know how many lines of instructions there are in the input or the example. So far, it looks like this example has 146 instructions. So I think I'm gonna, for this video, kind of build up the code in segments, kind of like what I have on the right side of the screen. Because maybe it's because I'm kind of tired and prone to mistakes, that I just want to make sure everything works as we're building up. So for line in 1 through number of instructions, what I think I want to do is initialize some values here. I want the cycle number to start at 1. I want the register x value to also start at 1. I might need something else there. What we're going to do is load in this instruction, which will take the puzzle input at this line, and what I'm doing there is, if there's a space, we're going to want to split that up later. If there's nothing there, I think this line of code should still work. So if this instruction's first element happens to be that no op, what I want the program to do is take the cycle number and add 1 to it. And I think what I'll do for now is just double check that this part of the program is working by printing out a statement here. So the cycle number goes through. And at least it is increasing. And that's all I asked the program to do so far. So what I think I want to focus on next is maybe getting the goal in place. That's probably the most interesting part of the code here in part 1. What I'm worried about is if you're looking for the 20th, 60th, etc. cycles, you got to make sure you do not accidentally skip those. So that's what I was missing up here. We need a signal. We need a signal strength. And because we're going to add to this a few numbers, we're going to start that at 0. And if cycle number. Now, the nice thing about R is typing in a list of numbers like this in a set sequence is relatively easy. Here, I'll do it in the bottom left corner. We're going from 20 to 220, counting by 40s. So we're grabbing these numbers here. And what I'm going to do in the logic of it all is say if the cycle number is one of those 20, 60, 100, etc., rather than having to make 1, 2, 3, 4, 5, 6 different if statements. I think for debugging purposes, I'm going to move the print statement up here. So now what happens when I run this code is that I get cycle number 20 to appear. I wanted both 20 and 40 though. That worries me. But I was also checking only for the no operation. So hopefully I don't have anything wrong at the moment. So the signal strength, as a puzzle implies, is the cycle number times the register X value. And I think I'll go ahead and, for debugging purposes, print out the current signal strengths and the sum of the signal strengths. It's not much right now. But I just want to make sure that the numbers are working. I forgot to add to the signal strings here, for example. Okay. So I got a bunch of 20s. I just got to remember wherever I'm at in the code, make sure to check for the cycle number being 20, 40, etc., 20, 60, etc. at the beginning of some decision making process. So let me add that to the pseudocode. With that said, here's what I was worried about. Because add v takes 2 cycles to complete, I need to check if cycle number is odd or even. First. So if it's odd, we're going to check for the cycle number. Actually, maybe not. Let me go back. We're going to check for the cycle number. Add 1 to the cycle number. We're going to check for the cycle number again. Add 1 to the cycle number and then update register value. I think that's the order. Okay. So if this instruction is add x, the adder will be this instruction in the second spot. That is, if we have an add x line, the number we're adding is in the second spot after the space. And because the data was brought in as a string, I need to convert that to a numeric. We're going to put in this check here for the cycle number. We're going to add 1 to the cycle number. We're going to put in this check here for the cycle number. Not efficient code, is it? I'm going to add 1 to the cycle number. And then finally, update register x value. I should go ahead and comment my code. There we go. Well, well complemented code. Okay. I'm just going to run this code, see what happens. So at cycle number 20, we get that. Cycle number 60, cycle number 100. So it is coming out to the correct breakdowns. Let me go ahead and put the example back up here. At cycle number 20, we get a signal strength of 420. That's correct. At cycle number 60, we get a signal strength of 1140. Then reading down the list on the right hand side of the screen, 1800, 2940, 2880, and 3960 for a total of 13,130. Sweet. And then if I switch this for my input, I'm going to get a different number, and I got the right answer. Okay, on to part 2. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. In the system, there is no such thing as a vertical position. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, those pixels will be drawn. You count the sprites on the CRT. You count the pixels, sorry. 40 wide and 6 high. This CRT screen draws the top row of pixels from left to right, and then the row below that, and so on. The leftmost pixel in each row is in position 0. The rightmost pixel in each row is in position 39. Like the CPU, the CRT is closely tied to the clock circuit. The CRT draws a single pixel during each cycle. Current representing each pixel of the screen as a pound sign. Here are the cycles during the first and last pixel of each row. So cycle 1 starts here, cycle 40 ends there, then we begin a new line. The screen is 40 pixels wide and 6 pixels tall. So by carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel, represented by a pound sign. Otherwise, the screen leaves a pixel dark, represented by a period. The first few pixels of the larger example above are drawn as follows. So what I think I want to do is see if I could get the example going here in a way that's visible on the screen, that is. So let me just increase font size, and then we'll see if we can make sense of all this. Okay. The first few pixels from the larger example is drawn as follows. Sprite pixel has the first 3 pound signs. At the start of cycle 1, we begin by executing the addx15 instruction. CRT draws a pixel in position 0. During the next cycle, we're still handling the addx instruction. CRT draws another pixel, finishes executing at add 15, so x is now at 16. The sprite position is way out here, 15 units over. And things are getting complicated. At the next cycle, we're going to handle the addx -11 command. Because the sprite position and the is over here at positions, I should really count this. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this begins at position 15. Because the sprite position here at 16, 17, 18 does not overlap with position 3, or the third position, I should say, we're going to draw a period instead of a hashtag. Same thing on the next cycle, and we move the sprites down. I probably should have read off the ending before we got too deep into this. Allowing the program to run to completion causes the CRT to produce the following image. Now, the neat thing about this puzzle input is once we get this going, after you render the image by the computer, we're going to see what 8 capital letters appear on the screen. Checking the time, I'm kind of giving myself an unofficial half an hour to do this. It might be silly to keep copy and pasting the instructions if the instructions keep getting this long. Okay, so what I'm thinking right now is we're going to initialize some values like before. We need a cycle number that's going to start at 1. And we need some sprite locations. And I believe they start at -1. No, wait. Sprite position starts at 0. So this starts at 0. And just to save myself some headaches when coding this, I'm going to call these A, B, and C. Sprite, not spite. What I'm anticipating being a problem is having to deal with the 40 unit screen length. And some of these numbers are fairly long or large. Maybe not quite 40. So I just want to double check if I have to worry about where we are in the next line. I think I'll worry about that later. Okay. So what did we do before? We made a big for loop for the signal instructions. about whether or not the instructions were no op already add x. So I'm an R programmer and I like to store my information into a data frame. What I'm going to try to do is store the x coordinates and the y coordinates. For the x coordinates, I want the numbers 0 through 40. And I'm going to repeat that 6 times. For the y coordinates, I want the numbers 0 through 6. I'm going to repeat that 40 times. And then I'm going to make a Boolean variable. Technically, the instructions say to print these out in either periods or hashtags, but I could just use true or falses. I gotta be careful. The puzzle instructions started counting from 0, so it's 0 to 39 horizontally, 0 to 5 vertically. So now my data frame looks like this. I don't think it did what I wanted it to. What I wanted is that at every x coordinate, the y coordinates go from 1 to 6. Or 0 to 5, I should say. Probably just hard code this really quickly. I want 0 repeated 40 times. I want the number 1 repeated 40 times, and so forth. So now we have the x and y coordinates ready to go. We just gotta fill in some pixel locations, the hard part. Okay. So what I'm thinking of, instead of like in part one, we checked if the cycle number was in 20, 60, 100, etc. We are keeping track of the sprite positions and location numbers A, B, and C. So if the cycle number is amongst one of those A, B, and C, right? This X is cycle number mod 40. Module arithmetic. You just have to remember how to do this in R. And this is module division. Okay. This Y, we're going to take the cycle number, divide it by 40, but we're going to keep the floor or round down. And what we're going to do is we're going to go down the data frame, look for the row that has a certain X value, that has a certain Y value, and then fill in true. Well, at least the code doesn't produce any errors, but I don't know if this is actually working. Does not look like it. Maybe it'll all work out once I type in the rest of the code. Oh, the issue is that the beginning of the example starts with the addx commands, and I only programmed it to handle the no-op command. Okay. So now the idea is that if we run into an addx command, we're going to check for this cycle, do this cycle number thing twice. update the sprite position. So I got some trues and some falses, at least. I'm kind of worried because it's only putting trues on the top row of the graphic. That's probably not what I want. If I look at the right side of the screen, this Y is left at 0 for some reason. Let me double check that. So for right now, cycle number at the end of the loop is 241. If I divide that by 40, I get about 6. So when I take the floor of that, I should get the 6. But for some reason, this Y is 0. Okay, let's debug, folks. So what I'm going for right now is if at every cycle I'm just going to spit out the current numbers. Like so. Okay. So going from x coordinate, y coordinate. Okay, looking at the cycle numbers, these seem to be increasing property. Looking at the coordinates, 1, 0, 2, 0. And then goes from 0, 1, 1, 1. 2, 1. After 39 increases in the y value, so that all seems to work. Guess I need to figure out what my sprite locations are. What I want is for ABCs to always be 3 consecutive numbers. Now, I think that's the problem, because here my ABCs only added 2 by 2. The issue is that they were supposed to add by 15. Okay, so what did I do wrong here? The adder, even if the code worked correctly, the adder is supposed to end up at negative 11. For some reason, the adder is just the number 1 in my code. What's funny is the code for part 1 worked. So let's figure this out. The adder is supposed to start at 15. pretty sure. Or did I just not load this correctly? Oh, don't tell me that was what I did. Okay, I'm now a little more sure that I loaded the example correctly. The issue is that the so-called lit pixels are still on the top row at y coordinate 0. But the adder is working. So when the cycle number is amongst these, is true. Then we jump up, added 15. So now the sprite locations are at these 3 locations. 3 is not amongst those. So we do not like the pixel. We drop by 11. 4, 5, 6 makes that true. Scroll down quite a bit. So at this point, I'm worried that I didn't quite understand. The cycle number is supposed to get with the sprite locations, but the cycle numbers I'm seeing are much larger than the sprite locations. So I might have to do modular arithmetic on the cycle numbers as well. Let me reread the example. So notice that compared to the 40 pixel width, the cycle number is also supposed to be within the number 0 to 39 going horizontally. So how would I do that? Pretty sure I need to replace this cycle number here with the module 40 version. So now I have a bunch of true falses, which is kind of what I want. So now what I'm going for is a visualization. What I want is I want to take the data frame, send that into a ggplot, I'm going to play around with geom tile. Going to fill with is lit. So we get something like that. Now I'm going to make the x and y distances, the spacing equal. So we get something like that. I'm going to change the color scheme. I want, I think, black and yellow. So we get that. What's supposed to appear is some sort of English alphabet. Now, I need to show the y-axis so the number's actually counting down. I'm just going to do a quick Google search on how to do that. We have a transformation equals reverse. Or is it just this? There we go. So now the y coordinates you might be able to see on the left side of the screen count downwards from 0 to 5. Unfortunately, at the moment, I don't see this spelling out anything. Read the puzzle again. What 8 capital letters appear on your CRT? what I'm thinking of is if I separate the letters, it might be a little easier to see. But at the moment, I still cannot see what's going on. I've been counting incorrectly. Let me finish my thought here and then I'll fix it. Okay, so if we're 40 characters across, we're looking at 5 characters at a time. I'm going to load in a neat package in R called Patchwork. I'm sorry, I'm telling you, I still don't see it. What's supposed to happen is that the yellow pixels are supposed to form letters. Alright, the video is well over an hour long. I might just post a video to help people fall asleep at night. Well, hope tomorrow's puzzle will be better, and I'll see you then.